Okay, we are live. So we've talked about this before. We're talking about rational exponents, okay? So rational exponents. And the word rational, if you ever see this in an SAT, rational just means fraction. Sometimes on the SAT they'll say, describe the rational numbers. And you're like, what the heck is a rational number? So a rational number is any number that can be a fraction. Does that make sense? Any number that can be a fraction. So if you start out with a number to a rational exponent, the top number in the fraction is the power, and the bottom number is the root, okay? So we can rewrite this as the q root, whatever the root is, to the number to the power, okay? So if I take a look at this one, number 1, 9 to the 1/2 power is the same thing as the, okay? And something I want you to memorize, seriously, is anything to the 1/2 power always means just square root. Does that make sense? Because these numbers are kind of invisible. So anything to a 1/2 power is just a square root, okay? Does that make sense? And of course we know the square root of 9 is just 3. Easy? B has a couple of things in it. One has the negative exponent, so we know we learned about that yesterday. If it has a negative exponent, we're going to make it as a 1 over, okay? Cube root of 8 squared, okay? And I'm going to take this one step further. I know the cube root of 8, is 2, because what times what times what makes 8, right? What times what times what has to be 2. So then we get a 1 over a 2 squared, because I still have this square here. I have not applied the square yet, but I will now. 2 squared is 4, so it's 1/4, okay? Now you can do these on the calculator, right? You can. And of course I'm not against calculus, but you never know. You're going to get to a math class. You get to Massey's calculus next year, and you're not going to be able to use a calculator, right? So you're going to have to know these values, okay? So sure enough, even on my calculator, let me grab a calculator, I'll show you. Cameron, you like technology, I know that. So there's nothing wrong with using, in here, I don't mind if you use technology, so I'll just show you as well. If I went 9 to the 1/2 power, right, it's just going to give you 3, okay? And the same thing on this one, if you go 8 to the negative 2/3, whoops, negative 2/3 power, is it going to give me an error? Yeah, I knew it. Go back, delete that, okay, there we go. 0.25, which is 1/4, right? Same thing, okay? 27, now you can't use a calculator on 27 because of the x value, right? You don't know the value of x. So calculators will not do this one, but what I'm going to do is rewrite it as the cube root of 27x to the 6, okay? 1/3, so if 1/2 power is square root, then 1/3 power is cube, right? So we know, and then the cube root of 27 is like what times what times what makes 27? It's got to be 3. You guys agree with that? And then if I take a third of the exponent, you just get x squared, right? Not too bad? Thumbs up on that so far? Okay, good. And we've seen this before, haven't we? All right, now, this one says rewrite in radical form. Radical means a root. That's just and we've talked about that before. Radical means just any kind of root form. So we're going to take it from exponential into, we're going to rewrite it like this, okay? So we're going to take this as the 4th root of x cubed. That's it. There's your root, and there's your power. We're going to write this one as the square root of 6 over the square root of x. Here's my 1/2 power means square root. 1/2 power means square root, but I got a negative, so I brought it down. Okay? 1/2 power means square root of 6. 1/2 power means square root of x, but because of the negative exponent, I brought it down, okay? Fourth root, okay? You okay with the fourth root? Fourth root of y times the square root of y. Now, we could probably put these two together, and I'm going to show you how we could rewrite this a little bit differently. This is the same thing as 2/4. You okay with that? 1/2 2/4. So you could rewrite this one as the fourth root of y times y squared. Is this hurting your brain too much? Which is the fourth root of y to the third power is a better answer, okay? Okay, rewrite in exponential form. Okay, so this is the same thing as z to the 5/2. Because there's an invisible 2 there, right? We just don't write it, but there's an invisible 2, okay? I'm going to simplify this first before I rewrite in exponential form. So I do know that I'm going to have a 3 cubed root of 27 x to the negative 1 because I take a third of the exponent y squared. I'm going to take a third of the x to the 6. Okay, cubed root of 27, 3 times 3 times 3. Take a third of the exponent, a third of the exponent, and then finally I'll just write this as 3y squared over x. How am I doing? Am I doing okay? Okay, good. Now, C is not hard as long as we understand something about fractions. A lot of kids have a really hard time with C, but you guys aren't going to because you know how to do fractions, right? Of course you do. This is an x to the 1/4. X to the 1/4. Do you see the 1/4? Because there's an invisible one right here, right? Times an x to the 1/3. Because there's an invisible one right here, okay? Now, I'd like to combine them. I'd like to multiply them. And when I multiply exponents, I have to add. When I multiply, I have to add exponents. So I've got to add exponents, so I have to add. So to add, let me get a common denominator, okay? So I'll have an x to the 3/12 times an x to the 4/12, okay? 3/12 is 1/4, right? 4/12 is 1/3. So I have a common denominator, and I can add them. And I can get an x to the 7/12, okay? If you take calculus, you're going to do a lot of this kind of thing, okay? How am I doing, okay? Thumbs up. That was not too bad as long as we can add exponents, okay? All right, simplify. So I need to distribute. I'm going to take, this times this, right? X to the 1/2. And when I add, when I multiply, I have to add exponents. Add exponents. So I'm going to add exponents. Okay, so I'm going to multiply. I'm going to get an x. 1/2 plus 3/2 is 4/2. 1/2 plus 3/2 is 4/2 minus x to the 0. 1/2 plus a negative 1/2. Okay, just adding exponents, which is x squared minus anything 0 power is always just 1. The number 1. Anything 0 power is just the number 1. Okay. Okay. Now B has got 2 steps involved, and I'm going to do it the easy way. We could distribute and then divide. I'm going to do this first, just this first, and then distribute, okay? I'm going to go ahead, because this is 2x to the 1/3 times this expression divided by this expression. So I'm just going to divide these first. So let's see. 2 into 2 is 1. And then what do I do with this? Well, I have to subtract exponents. Let me do a little work on the side. Little side work here. I'm going to go x to the 1/3 power subtract a negative 1/3 power. Okay, I want you to see what I did. This is a little confusing. But when you divide, you subtract exponents. You agree? So I'm going to subtract a 1/3 from a negative 1/3. I said double negative, right? Do you see that? Subtract a 1/3 exponent, subtract a negative. We'll go 1/3 exponent, subtract a negative, which is really plus, which is going to make an x to the 2/3. You okay with what I did? Subtracted a negative. Or I could just bring it up. That's another thing. I just bring it up. And if you think about it, if you bring it up, you get x to the 2/3 either, right? And then we still have times the 3x to the 1/3 plus a 4x to the 4/3. Okay, now I'm going to distribute. And when I distribute, I'm going to add exponents, okay? So I'll get a 3x to the 3/3, which is 1, but I'll change that in a second, plus a 4x to the 6/3. You okay with that? So you can see this is just the same thing we've done in Algebra 2, just the difficulty level's a little higher, right? So it's a 3x to the 1. I don't need the 1, but I'll put it in there anyway, plus a 4x squared. Again, I don't need the 1 right there, but I put it in there anyway, so you guys can see it. Thumbs up, not too bad. So it's the same things we've been learning in Algebra 2 and in Geometry and Algebra 1. It's just more difficult problems. Makes you think more, right? Okay, because we're smart now. Okay, all right. Solve for x. Well, here's the thing. You can't divide by 8. You have to think about it, okay? So what I want to do is this. The trick is to make the same base. You have to make the same base. So I know 8 is the same thing as 2 cubed, right? And 32 is 2 to the 5th power. Okay? So once I make them the same base, here's my 8, here's my 32. Once I make it the same base, then it's really 3x equals 5. Because 2 to something equals 2 to something, so obviously it's the somethings have to be equal. So I can just say 3x equals 5. So you got to make them the same base. And then just solve. Divide by 3x is equal to 5/3, okay? So you have to make them the same base to make it work, okay? Right? B. Well, I think 125 can be a 5, right? 5 to the 3rd, right? 5 to the 3rd. So 125 is the same thing as 5 to the 3rd. That's 125, right? 5 times 5 times 5.
So,
yeah, good.
Also, if
Dallin, I'm listening. Go ahead.
if that is 5 to the 3rd equals 125, then that's the other one is already that. So could you make them both 125? So it's just 125 to the power of x equals 125.
That's really clever. That's super clever, except for the +1 messes you up. But you know what? Dallin, that was a really creative idea, because there is your 125. I think so. Dallin, I've never done it that way. Wow, after all these years, you're the first one to see it that way. Nice job, Dallin. Okay, I'm just going to keep solving it this way, okay? I got a 3x equals a 3x plus 3, right? I got to fix this problem because there's no solution. I got to change this. Minus 3x, I got 0 equals 3. There is no solution. That's a bad problem, but I like how clever you did that. Do you guys see why there's no solution? Your x's cancel, right? You subtract 3x. I got to go back and fix this problem because that's not a good problem. I didn't really want to know a solution. But Dallin, you're totally right. Hey, nice job, clever girl. All right, C is the same thing, okay? You can't multiply these. In fact, I'll give you an example. They're different. You guys agree? They're different. So if I had, for instance, just example, just want you to see this. Don't multiply these two. Don't. You think, oh, 2 times 4 makes 8, right? Don't. These are different. If I had x to the 3rd times y to the 2nd, you can't do those because they're different. You guys agree with that? You cannot multiply these. You can't add their exponents because they're different. These are different, but I can make everything the same base. I can all make them all into x's or all into y's in a sense. So I'm going to make this 2 to the third. Okay, that's my 8. Okay, there's my 8 equals 2 to the 5th times 2 squared, right? Because that's my 4. And now, because they are the same bases, they're like both like x's, I can add the exponents, okay? So I'll get a 2 to the 3x equals, well, I'm going to have a 2 to the 5 plus 6x. And I'll let you think about what I just wrote, okay? So when you multiply, you add exponents, right? When you multiply exponents, so I'm going to have a 2 to the 5 plus 6x. You get that? When you multiply, you add exponents, right? So I'm just following the rule. And now they both have the same base. So I go 3x equals a 5 plus a 6x, right? And then it gets pretty easy from there, right? Let's see. Let's go minus 6x, minus 6x, negative 3x equals 5, right? Divide, and I get x equals negative 5/3, okay? Okay, how am I doing? All right, same base. How about 3? We can change them both into a 3, right? So I'm going to change this into a 27 is the same as 3 cubed, right? There's my 27 equals 1 over 3 squared to the 3 minus x, okay? I'm going to do one more thing, and I'm going to bring this one up and make it a 3 to the negative 2. You okay with that? Because then I got 3 to something equals 3 to something, right? So I'll rewrite this as a 3 to the 3 times x minus 1 minus x equals a 3 to the negative 2 times that 3 minus x, okay? And now I've got 3 to something equals 3 to something. I got the same base. Since you can cross out the bases and solve. So I can go 3 times a 1 minus x equals a negative 2 times a 3 minus x. Okay, and I'll let you catch up. Am I doing okay? Okay. I mean, it does still follow all the same rules, right? So then I'm going to get 3 minus 3x equals negative 6 plus 2x, right? Plus 3x plus 3x. I'll have 3 equals negative 6 plus 5x. Add the 6, and I get 9. I'll squeeze it over here. And divide, and I get 9/5. That was a good problem. I like those. Those make me think. Okay, number 7. Let's see if we can set it up. So same problem we had, same type of formula. We had the y equals our a times a 1. Okay, this is growth rate, right? Growth. So I'm going to go plus. It's growth rate. So I'm going to go plus 1 plus r to the t power. Same formula we've been using. The house was bought for $250,000. So I'll put that here. About 250,000. 1 plus. Now in this example, we're trying to find the growth rate. Okay, we're trying to find the rate, so we don't know. Let's leave that as R. Oh, I ran out of time, you guys. Really? No. Time flew that fast. Okay, real quickly. Don't go real quickly. Here's what you got to do on this one before you go. Okay, 400,000. So when you're eventually going to take, is it 10 years? Yeah, so eventually going to have to take a 10th root of this and this divided, okay? You'll have to take a 10th root, and then you'll have the 1 plus r. Yeah, I can, well, okay, homework, you okay on the homework, I think? And I can go back over this one tomorrow. Man, time flies when you're having fun, huh? Bye, you guys. How'd that happen, Cameron?